With me today. I work at CenturyLink. I came there via an acquisition. My job at CenturyLink is kind of an odd one. It's to build some of the things we used to buy. And so I don't buy a lot of stuff. I don't do a lot of standards-orientated work. I run an engineering team that came from the vendor side of the world, and we build some of the things that CenturyLink used to buy. And so when I came here, one of the things that, actually before I do this, let me ask a couple of questions. So firstly, a bit of a show of hands. Who's in the building things? Engineer, developer, product, program manager, building things, great. Who's in the sales and marketing side? Come on, sales guys, put your hands up. It's okay. You make the world go round. You know, without professional relationship managers, nothing really happens. And then, so who are the runners of networks? The runners of networks and the people who provide them the services and products that do that? Okay, I got a good sense. So I'll be relatively technical as I go through a bunch of this stuff. So one of the things they asked me to take on when I got to CenturyLink is they said, look, we've got this NFVi program, and you know, perhaps you could take it over. And CenturyLink had been in the NFVi business for a fair while. And in fact, the first version of this thing we call PSB VMware was started in 2012, 2013. And it was a very successful program. And there's a reason that it was really successful. It was built out of necessity and scarcity. And by that I mean the guys who worked on this project, they were faced with the problem of doing a major appliance upgrade that the company could ill afford. And so they went out and figured out how to do this with virtualization. It's not a full stack system. It just does virtualization. It only delivers one product, but it's very successful. We have thousands and thousands of customers on this thing, and it worked very well. So that same team of guys said, so now that you did such a great job there, they said, go build our next generation NFVi platform. And so they were given, virtually unlimited budget to go off and do it. And I arrive, after this project is, well behind schedule. And that's okay because, as I think as Pat said earlier on, I mean, failure is the building block for success. So it's okay to fail, but it was behind schedule. So I sat there and I thought, all this money, all these vendors, got to be minor problems. How hard could it be to get this into production? How wrong I could have been. So it turns out that what had happened along the way is that these guys had built a very, very complicated system. And we were on this trajectory, like carriers seem to always be on, that each system is more complicated than the last. Really challenging the operational teams to be able to take this stuff into production and manage it, and the rest of the organization associated with it. And we need to be off that path. I mean, the next system has to be simpler than the last because, ops is already challenged by, managing these systems. And of course, complexity has other problems. It has problems associated with velocity. Complicated things are hard to get going. And it has problems associated with reliability. Now, I will tell you, we have some of these in production, not a whole lot of them. They are sufficiently reliable, and we do have customers on them, but they're not where we needed to head to. So between June and kind of November of that year, we went back and it became very obvious to us that we needed to do something different. And so at the end of 2016, we embarked on a new project and we built a brand new NFVi platform that we call PSB OSN. And again, it's a full stack system, but different from the previous system where there was all this money. It's only designed for NFVi. It's not for generalized workload. And of course, the other thing that's common with the first solution is that all the money was already gone. I couldn't go back and say, give me another pile of money to build this thing. I had to go and do this without a whole lot of money. So we went and broke this down into a bunch of different parts, and with the benefit of the guys that had worked on this experience, we were able to break this down into some component-wise systems and go off and build this complex. And we rebuilt the whole complex with no vendor code other than some source code that we bought for our white box switches. And so we did extensive evaluations along the way to figure out build versus buy, but at the end of the day, what we kept running into was a lot of complexity in vendor solutions. So therefore, we chose to go in this path. So these are the different pieces. The management platforms, they're running Kubernetes. They're in multiple locations to give reliability. And I'm going to talk a little bit about Victor quite a bit today. That's a piece of open source that a piece of code we're about to open source. And then we have a domain manager. Her name's Elvira. And then Raji is our platform underlying infrastructure manager. So things are broken down, right? The team that builds the NFVi complex and does all of the initial bootstrap and management of the actual hardware platform, They're a separate team and they do all of this platform management. There's another team that manages the system when it's in operation from a VNF perspective, not from a platform perspective. And then inside the platform, we run OpenStack. Heaven knows why, but we run OpenStack. And then, of course, we also went down the path of taking out a lot of complexity and put white box switches in as well. So we have Broadcom-based white box switches with our own network operating system on them that allows us to automate the system. And you may ask why we did that as well. Again, a lot of this comes down to how can you automate and simplify, and how can you keep driving on down that path of the next system is simpler than the last. Just so you know what one of these things looks like, this is a kind of a very small pod that sits in one of our COs. It's in the build stage at this point, so it's OpenStack. We package completely from source, CentOS KVM. We have to be on that pathway because a lot of CenturyLink's customers are US government customers, and you need to be in the Red Hat family to be on that path of supporting those particular customers. So we can easily interchange Red Hat in and out where we need to. Minimal components. It's designed for doing packet-based forwarding. Now, we do have some pods that are designed for more generalized purposes. When you deploy a Palo Alto firewall, you kind of deploy the management system for it and then a whole bunch of firewalls, right? And so we have to have somewhere to deploy the management system as well. So we have a number of pods that have lots of storage in them and all of those sorts of things so we can run analytics and stuff like that for the customer. But spread largely throughout the network in all of the interconnection points are these ones designed for packet processing. And then our white box switches, we call it SOS. I've been in the routing business a long time, and I've always wanted to call the switch operating system SOS. And so, no marketing organisation would ever let you do that. So here we don't have one, so I just called it SOS. So we have our own network operating system associated. And this stuff's in production. So to give you a sense of velocity, and I said, complexity drives velocity, the last version that we call OSP, the one that we have some in production, but weren't meeting our reliability requirements and our time to market requirements that we wanted to get to. Those systems were taking approximately 6 weeks to install. And so we didn't have great automation. We had a whole lot of traditional carrier processes where, the traditional silos hand responsibilities off backwards and forwards. And what we learned as we tried to deploy this style of platform is that the traditional workflow of deploying routers and switches and all that other stuff really didn't work because there's networking in the compute and there's compute in the networking and it's all a big mess. And what we found was going on is that through these functional groups, the actual work order was bouncing backwards and forwards. And any of you from the carrier world know that work orders don't go backwards, right? I mean, they got to close because you've got to capitalize the project. And so what we did is we went and did a whole lot of automation, but the most profound thing that we did is we changed the workflow. And when we changed the workflow, we went from more than 6 weeks to 2 days. So half a day to do wiring, and not unsurprisingly, the wiring instructions that we had in the first iteration of this described how Ceph worked and how OpenStack worked. And, the guys in the data centers and the COs, they don't care about any of this stuff. I mean, I don't know why even writing this. Our current procedures look like IKEA manuals. And as frustrating as IKEA manuals are, they're far better than the manuals they used to get. So now it takes a half a day to wire, half a day full automation install. My team does that. We have a kind of a breakdown where major upgrades are done by development, maintenance and patching is done by ops. We're really not in the DevOps game. It's too hard to get there. And then we run for 24 hours in a burn, hand it over. So a very different process. We're able to roll these things out in a couple of days, take them to production. So switching gears back to automation for a second, how do we automate this now that we have the system in service? So you may be aware that last year the company went through a large acquisition, which was really much more emergent than an acquisition of a company called Level 3 Communications. And I happen to be on the integration team. And one of the things that we were challenged with, and I think last year Travis gave a keynote at this same conference, and one of the things we were challenged with is how do we merge all that stuff together? And as we've been speaking with vendors about orchestration systems, one of the things about orchestration systems is everyone wants to be in charge. I mean, everybody wants to run the whole thing, and that was just completely impractical inside the environment that we had. We had tools for all different things. So we went down this path. We decided that we would build a master orchestrator, which we already had a bunch of code to do that in place. So again, code built by CenturyLink, some from our cloud organization, some from from the level 3 organization, merged together to give us a master system to Orchestrator. And then we said what you need to do in each one of your domains is build a complete turnkey system to orchestrate your domain itself. And we had a heated conversation, or a healthy conversation if you like, about the logic of merging together VNF orchestration and PNF orchestration. Should you use the thing that manages the routers to manage the virtual routers? We determined to not do that, and we left the PNF orchestration where it is, and it's fairly common knowledge we use TailF for that, and we left it where it was. And let me tell you the reason why. It had nothing to do with engineering. It had to do with, we have this big business running in the business of managing and configuring routers and generating revenue. We've got this little emerging business that's all virtualized. And we felt that it made much more prudent business sense to not disrupt A with B, not put a whole lot of new features into B that could disrupt that revenue generating process, and so we decided we would keep them completely separate. But from a technical perspective, you also want to think about something else as well. The amount of work we would have had to have done to bring the PNF automation into the VNF world is fairly significant, because what the PNF automation expects to see is a device that exists. The device doesn't exist before you start with the virtualized world. And so, therefore, all the work that we needed to do was to go and create this device, and we would have had to do that somewhere no matter what we did. So that's what we have. I know a lot about the PNF world. There's a whole bunch of other stuff here. And of course, my team did the NFVi world. So it's fully autonomous in each of these individual domains. You build your own management system, you build your own orchestration system, you build your own hardware management, and that's the only way we could really scale the system out. Too many cross dependencies. So now we're presented with this challenge that we've got to get something that talks to a lot of different things. So we've got to talk to all these different vendors. We've got the PNFs to talk, the VNFs to talk to. We've got the underlying hardware to interact with, OpenStack. In our services, we talk to lots of different things. So we've got to go and talk to the MPLS network, figure out which VPRN you're on. Some place we've got to talk to Equinix. We've got all these different things to talk to for all these services, and we had to figure out how to go and do that. So we had this diversity of services, lots of different models to go off and do it, and we needed to deal with each of these elements. But the most important part of this was realizing what was going on inside the IT organization. So as I watched what was going on inside IT and why IT projects are always late inside carriers, is because the network engineering guys come up with some new product, and their idea of transferring that product to IT to complete the project is to try and get the IT guys to learn about the technology. But these IT people were hired to do databases and Oracle and Java, right? And so someone comes in and says, well, you've got to flip the label, and the labels are 7 labels deep, and it's like, so not unsurprisingly, IT spends its life trying to figure out how to become network experts so they can complete their projects, and their projects don't work. So we sat there and said, we got this problem, how do we solve this problem by letting the network engineers abstract it and then provide a product or a web services or an interface up to these IT guys so that they understand it. If we can break that puzzle and get the network guys to put their knowledge in a programmable form into the system and then pass it to the IT guys, we'll be in a very different situation. So that's the path we went down. And the solution to this was something we call Victor. And so what Victor is our version of VNF orchestration. And so from a technology perspective, on the southbound side, there's the usual things you'd expect to see. It does netconf, does Ansible. We use Ansible throughout the company, so we do a lot of Ansible in here. And incidentally, the reason I bring up Ansible is that when we do our hardware management, bringing up the OpenStack systems, all of that's done in Ansible. That said, in other parts of the business, everything's netconf, so we have to be able to do both things. Then we have a web services library, so you can do anything like that, and we have an OpenStack system that goes into this. And I'll go into a bit more detail as to how this thing works, but basically it has a graphical interface that allows you to go and create a workflow of functions that makes a lot of sense to a network guy. And that set of functions that you go and create that makes a lot of sense to the network guy, where it fills in parameters and stuff like that, talking to each of these independent systems, auto-generates a web services UI, web services interface, that's shoved into Swagger such that an IT guy can look at a web services or REST API and go, oh, this makes sense to me. These are the 6 parameters I need to put into it. And it also auto-generates a UI that you can use to go and make this work. Now, incidentally, as we were going down the path through this, we did take quite a close look at ONAP. And there are pieces from ONAP in here. So we didn't say we're going to adopt ONAP. We took to the next level of abstraction and said, hey, what's in here for our purposes? And so a couple of pieces that we took out of ONAP that we used in this thing, one is there's a piece of logic inside there called the Service Logic Interpreter, and it's basically the directed graph walker. And so we took the directed graph walker and then went and built all of our logic around it. And then along the way, we looked inside this thing and said, hey, this is all inside Open Daylight. And we have a separate project that has Open Daylight in it, and we have Open Daylight controllers. But it comes with a lot of burden. You know, Open Daylight's not an easy environment to operate in. So we stripped the whole thing out of Open Daylight and then went and just turned it into a basic set of Java virtual machines, and now it's a bunch of containers. And so we took it out of that same puzzle. So we didn't write all of this code. We did go down the ONAP path, and we intend to open source this inside, Linux Foundation. But we took that next step down to say, I'm not going to adopt ONAP, but gee, there's some great stuff in here. So Victor, what kind of happens here? Usually I do a demo here. In fact, the most recent time I gave this presentation, I got up and logged into production. The cloud scale guys do this all the time. They log into production and do demonstrations. Seems like carriers can't do that. Ops won't let you for some reason along those paths, but I do it. And the last conference I was at, I launched some services in production and showed exactly how this thing works. But in the interest of time, which is 3 minutes and 15 seconds, I won't do that. I'll just finish talking with this today. So we took 2 things out of ONAP. We took out the Service Logic Interpreter, and we also took inspiration from their Node-RED component. If you don't know what Node-RED is, it's a front end to Node.js, and it's really an educational tool. It's for people who don't really know how to write JavaScript yet, and you basically, have this drag and drop screen where you can drop boxes on with functions, and you can write functions into these boxes, and you can create little pipelines of things. And we use this in a lot of places. We use it primarily in places where we've got very talented network guys, but not very talented programmers. So it allows them to go and understand the environment without having to try and take these guys all the way to being programmers all the time. So we have this in lots of places. Ops, little converters of traffic, little things that watch particular databases and send alarms. We have a lot of these things. And the reason to use this is such that ops and non-programming people can get inside this thing and actually understand the logic and make it work. So we have the same thing. So what happens when you go off and you want to activate a service, you basically go into this thing, the service designer, and if you've seen the ONAP presentation, it's not dissimilar. You drag all these boxes across. It has a set of queues. You march your way through it. Say, make me a VM. Now that the VM's up, connect it to the MPLS network. It does it a certain way to talk to a device that does that. Go inside the VM that's spun up. Do a configuration associated with that. Perhaps, you talk netconf to talk to a Juniper router inside that process. And as you step your way down the tasks, it passes the parameters along. So you basically go through this process of configuring all that up. You set the parameters that should be in the API, that should be visible above. You hard code the stuff that you know not need to be there. And you can do lookups to other systems to get those answers as well. So instead of there being 50, 60, 70 things to go and configure to bring up, some device, and you'd be surprised even in a simple routing configuration where BGP is involved, how many things you've got to do, you abstract that down to the minimum set of functionality that you need to do. So you create this thing. Once it's created, it auto-generates a user interface that is, utilitarian, but it reflects the configuration that you just did, only showing the mandatory and optional parameters. So a traditional provisioner can go into this thing, and if they were to do it by hand, go down through that configuration thing, and it's all automatically generated. And then the second thing that it auto-generates is a web services UI. And if you filled in all your descriptions correctly in all these fields, it puts them into Swagger, so you can go into Swagger and have a look at the web services UI and say, oh, this is a web service to spin up a Juniper router and the following stuff, and here's the descriptions of all the parameters, and so you can hand this up to someone who works in that part of the world. In addition to this, however, we also have a vertically integrated UI that we had developed for a very specific use case because we needed to solve a specific problem. So we do have a vertically integrated UI for a very particular application that we serve. And the great part about that was it helped us build the thing that the IT guys would use or the next people upstream would use and get it built right. So we do have a bunch of this stuff. So why did we do this a little bit differently? And so when I talk about hybrid orchestration and getting to the end, but the start of my presentation, when we looked at the platforms in the marketplace, what we found was a couple of key things that we felt were not ideal for our business. And so one of them was that every single system wanted to be authoritative over the whole complex. So the orchestration guys come in and say, you buy our system, it runs everything. And you go, okay, that's great. But what happens when someone at 3 o'clock in the morning on Sunday logs directly into a system and makes a configuration change? And the first words out of everyone's mouth is, well, they're not allowed to do that. They've got to go through the automation system. And the reality is it never happens. I mean, the reality is they log in at 3 o'clock in the morning, they make changes. So now you're no longer in synchronization because you've tried to make something different, authoritative in the platform. And so you've got to synchronize. And so the answers to synchronization were kind of twofold. Some vendors understood the synchronization problem in great detail because they knew how hard it was to do. And those who did it understood the limitations and the probability of heading to NP complete in a very large complex. Some of the other vendors turned around and said, oh, you've got to write code to do that. And we're like, hang on, what are we buying from you guys? So we took a different approach. We said, look, the network is authoritative, not the orchestration system. So we go and we make the NFVi pods. That's what's authoritative. And bear in mind that in the carrier world, there's lots of little OpenStack systems. There's not one big OpenStack complex. There's lots and lots and lots of OpenStack. In fact, 50 of these things in varying sizes spread all over the world. And so we make it authoritative. And Victor plays a very specific role. You call this thing to go and configure a service, and it goes through the process of creating the service, ensuring that it's created exactly. If it fails along the way, it backs it out. And then once it has finished doing it, its job is done. It doesn't monitor it. It doesn't stay on top of it. We have a sister system sitting next to this thing that we call Elvira. Everything's got a name. And Elvira is keeping track of every single piece of telemetry coming out of systems based on ELK. And so it keeps all the data associated with everything that's going on. So we know every single thing that's going on inside the system. Debug logs, the whole lot. And if we want to go and figure out what's supposed to be there, what versus actually is there, we just want to compare against the two and look at the fallout rate. And so instead of trying to solve this really complicated synchronization problem, we said, let's not go and solve that problem. Let's assume, I keep hitting that thing, let's assume that capacity planning is doing their job, that there's always resources available, so we're not in a situation of scarcity. And then let's also assume that we'll have a fairly small fallout rate. So that's how the system kind of fits together. We made everything else authoritative, and we avoided solving the really complicated, centralized problem of it knowing everything about the network. So I'll finish here, because I'm over time. And what the lessons of this is, decoupling this into multiple different groups and the way that we built it made the thing pretty easy to build, relatively speaking. We rebuilt the thing in 12 months. This whole thing, including the white box switches, we built, took it into production in 12 months. And so for those of you who are people who have done this, you will realize, you marketing guys are sitting there going, no, everyone does that. The people who have actually done this will realize that was a Herculean task. And I had the benefit of basically having a bunch of startup guys that we brought into CenturyLink with me as a team. And so they moved at startup velocity as we did this. So I was able to get that done. And then horizontally focusing it reduced our requirement set, and thankfully we were able to grab open source from other places to make it work. And we are in the process of packaging for release to open source, probably in Linux Foundation. Perhaps people will call it ONAP Lite. We have, in addition to the NFVi platform, it's actually showing up in lots of different places inside CenturyLink because it's an easy way to just do this abstraction A to B. And we have a number of our customers who have asked us if they can have it too to do this simple abstraction A to B. So with that, I'm over time, so I won't take any questions. We'll just get to the next bit.
Yeah, have a seat. Yeah. Great job, Adam. Let's give it up for Adam. I'm going to ask.